Hey, good morning, Panthers. I'm sorry that I'm not with you today. I'm attending to some family business this morning, so even though I'm not here, the learning will commence. By now, you should have page 121 set up in the ISN. We're going to graph to solve some problems today. You've got the white sheet that we will glue into this page, and we'll make the glue available to you after the teaching part of our time together today. I'm going to temporarily move this out of the way, as I often do, so we can focus on the task at hand. So we're going to look at three problems that go in the ISN together today. The first one goes like this. Apologize for a little bit of printing trouble up here. It says Troop 200 sold cider and donuts to raise money for charity. They sold small boxes of donut holes for $1.25 and cider for $2.50 a gallon. In order to cover their expenses, they needed to raise at least $100. So what it first says is write an inequality that describes this scenario. Let X be the number of boxes of donut holes, and let Y be the number of gallons of cider. Part B is going to ask us to make a graph of the inequality. And then Part C asks us to list at least three possible combinations of boxes of donut holes and gallons of cider that will allow Troop 200 to reach their goal. So let's go back here and look at Part A now. Part A says write an inequality that describes this scenario. Let X be the number of boxes of donut holes, and let Y be the number of gallons of cider. To me, a key part of this problem is that they need to raise at least $100. They must make at least $100 out of this. So the money that they make has to either be equal to $100 or has to be more than $100. So that makes me think that for A, we're going to write something is greater than or equal to 100. And that something should be the cost, or rather the money, that is collected from selling each box of donut holes and each gallon of cider. So to sell boxes of donut holes for $1.25, that makes me think that $1.25 times X. Let X be the number of boxes of donut holes. So if they get $1.25 for each box of donut holes, then that number times $1.25 will tell me how much money was made. Similarly, I think I can write an inequality that talks about the cider. $2.50 for a gallon of cider. If I'm letting Y be the number of gallons of cider, then I think I also am going to gain $2.50 for every gallon of cider. I believe this inequality, 1.25x plus 2.5y, is greater than or equal to 100, satisfies the need in A. What I need to do now is I need to graph the inequality. I need to graph that inequality in Part B. So I know that yesterday we talked about solving this thing for Y. I don't really want to mess around with that today. I think I want to find the intercepts. I think I want to find the x-intercept and the y-intercept, and then I want to graph. So to find the x-intercept of this, I need to think about taking the equation, or excuse me, it's not an equation, it's an inequality. 1.25x plus 2.50y is greater than or equal to 100. And I think I need to get rid of or cross out, if I want the x-intercept, the y term. So what I need to solve is 1.25x equals 100. And what I know is that I can divide both sides of that equation by 1.25 to get the x-intercept. If you're not entirely certain what 100 divided by 1.25 is, don't be afraid. Let me switch over to the calculator here to use the calculator for that today. 100 divided by 1.25 is 80. So I get x equals 80. Or in other words, right here, this is the x-intercept for numbers of donut holes. And I can do a similar thing to find the y-intercept. To find the y-intercept, I want to think about crossing out the x term. So 2.50y equals 100. And if I divide both sides of that equation by 2.5, and I will check that on the calculator as well, 100 divided by 2.5 is 40. So now I can graph the y-intercept as well. This inequality had a greater than or equal to in it. That tells me that the line that connects those should be a solid line. Try to do the best you can to make the line graph. And then I need where the money raised is greater than that. This line is where the money raised will be equal to $100. I need where the money is greater than that. I need all this part up here. So anything in this region of the graph or beyond should solve the problem that the Troop 200 has. So there is our graph. Now part C says, list at least 3 possible combinations of boxes of donuts and gallons of cider that will allow them to reach their goal. In other words, give me 3 ordered pairs that are in the solution set. So anything that's either in the shaded part or on the line works. So here's one that works, right here. And what is that? That's 30 donut holes and 40 gallons of cider. So we'll list that. So one option is 30 boxes of donut holes, 40 gallons of cider, let's pick another one. Here's another one that works. And you can pick any one of these. I'm just picking ones that jump out at me. There's 70 donut holes and 20 gallons of cider. 70 boxes of donut holes. And 20 gallons of cider. And just to show that we can use anything on the solid line, let's pick this one too. That one works. 40 boxes of donut holes, 20 gallons of cider. There we go. Problem solved. Okay, let's take a look on the inside here. If you want to take a second to turn on the inside of this white paper. Let's talk about David going to the comic book store. David is headed to the comic book store where he can buy comic books for $3 each and packages of game cards for $1.50 each. David is taking $15 with him to the store. So we want you to write an inequality that describes this. Let X be the number of comic books. Let Y be the number of packages of game cards. So here again, he's taking $15 with him to the store. That means he can spend exactly $15, or he can spend, in this case, less than $15. So here I think our inequality should be a less than or equal to. If we're going to write an inequality that talks about what David can spend, he can either spend exactly $15 or he can spend less than that. So let's use less than or equal to. Now what can we write? If X is the number of comic books and they cost $3 each, then how about 3 times X? He also could buy packages of game cards for $1.50 each, 1.5Y. If you want 1.50, that means the same thing. So part A is taken care of. Let's do part B. Let's find the x and the y intercepts. Okay, to find the x-intercept, I need to cover up or forget about or cross off the y term. So the equation that's there says 3x is equal to 15. And if 3x is 15, I can divide both sides of that equation by 3 and get x equals 5. So there's my x-intercept now. The scale on this graph appears to be given as 1 tick mark per unit, and unless I've got a reason to not use it, I'll just roll with that. That should be fine. To find the y-intercept then, I need to cover up or forget about the x term. So the equation to solve is 1.5y is 15. If I divide both sides of this equation by 1.5, I think I can figure out what y is here. 1.5 and 15 are the same two digits in the same order, just with the decimal point in the different location. I think that's 10. So y is 10 is the y-intercept. 3, 4, 5, 6, 7, 8, 9, 10. Right there. And I can now connect these 2 points with a line. And again, I'm going to use a solid line because the inequality has less than or equal to. So here the line represents what David could buy to spend exactly $15. If I also want to include where he could spend less than that, I want the part below the line this time. Okay. There it is. There is our inequality. Part C then says, okay, so list at least 3 possible combinations of comic books and packages of game cards that David can buy. Here's what we're going to do. We're going to pause this video, and we're going to give you about 2 minutes to try and write 3 of those. And once you've had those 2 minutes, then we will hit play, and we will talk it out. Try part C. Okay, welcome back. Let's see. You could have chosen any 3 points in the shaded part of this graph or on the line. So here's one that obviously works right here. That would be 3 comic books and 1 package of cards. So 3 comics and 1 package of game cards is an option. Here's another one that works. Right there. It's near the line, but it's definitely in the shaded part. He could buy 2 comic books and 5 packages of cards. So 2 comics, 5 packages of cards. I'm writing PKGS like an abbreviation for packages. And let's find one more. Oh, here's one where he can spend exactly $15. That would be 4 comics and 2 packages of cards. 4 comics, 2 packages of cards. Very good. And I bet you came up with some really good ones as well. We have one more problem to look at, and it's on the next video.